No, I should have upgraded my four.
Great. Okay, last time we were looking at practical optimization problems, I think. So, next. Can we see okay? Oh, no, we can't. Could you adjust the height if you push the tower back? There we go. A little more. No, too high. There we go. Ooh. Great, perfect. Okay, next lesson after the optimization. You need someone or to talk to all of them?
No, I want to talk to you.
Me?
I was actually going to kind of bend down a little bit lower and just like have my bone kind of slowly go across the window.
It's like having a shark fin.
I just want to ask you a question.
Yes.
Inside,
outside?
Are they right?
Can you take out the last lesson, the practical optimization one, and just continue with your next question on that, okay?
No.
Yeah.
I'm taking your discussion.
No,
you're not. Right. When you're probably there,
To give our new kit ID, not how
the whole thing that you need was when I was asking you.
this.
So basically,
Oh, yeah.
This is kind of the correspond to the guy right click.
Not in use.
And then this is me.
You are.
Yeah. And then the field looks like
Yeah. Okay. This seems okay.
Can you confirm the reverse enrollment? Is that not a confirmation? No. Reverse enrollment. Why did you ask me this question? I gave you a really nice task because I tell my I didn't understand the question either.
So, did you want to have him proceed on this one? Or do you think that would be...
No, I just wanted to get it anyway because so I wanted to so I just basically need to say, as I said in my previous email,
yes.
Which I'm going to say because I'm
yes, so it's all movements on Dublin server, that can all be gone because our Moodle is on so like there's two Moodles on this and one on this, and these are the old ones and this is the new one, and this is the original one that they were griping at us to get rid of because this is at the same location as the DISC website. And they don't want the two together, so these can be gone. They shouldn't have access to this though because you have the name and password, so they could, even if they wanted to delete this, they couldn't because it's on an account that we bought with the company, so I'm so confused by why they're so into this.
Would it be okay if I just forward this?
Yes. Yeah.
Wait a little bit then.
And then she can do.
You know what I mean? I'm not
Yeah, but it's a bit mad because we came up with this last year, so what's the urgency of it? Something about it. You want me to email or will I wait?
No, I'll
You'll forward it on and I'll reply all.
Yeah, I'm just answer, yeah.
You'll forward this and I'll reply all. Or whatever.
Yes, that would be right, but, yeah.
Okay.
Wow.
St. Patrick's Day is coming the right day tomorrow, is it? See ya.
See you later.
Okay, as I was saying, so the practical optimization, I have a feeling that on Monday's tutorial it'll probably be spent doing these questions. I'm sure you found some of them very hard, right? Just before going on to the next topic, which is actually, you'd be pleased to know, quite easy, I just wanted to say something for the economics students. Recently you did with Donald marginal revenue and marginal cost. Yeah. And Donald told you to maximize profit, you say marginal revenue equals marginal cost.
Yeah.
Did he say why?
No. It just said.
I shall say why now, if you're curious. So what is the definition of, this is only for economics students, but you are welcome to listen to, what is the definition of marginal revenue? What did he give you there?
Change of total revenue over total quantity, like a change of
Yeah.
quantity.
So in other words, it's the derivative of revenue.
Over derivative quantity.
The change in revenue per change in quantity. And what did he say marginal cost was? The change in cost per quantity. So that is the RDQ. Yeah. Now, what's the formula for profit? Total revenue minus total cost. To make this a maximum, we need to calculate the derivative and make the derivative equal to 0. So this is the derivative of revenue. But what's the derivative of revenue? We call that marginal revenue. And what's the derivative? What's the derivative of cost? We call that marginal cost. And what should that equal? 0, because it's a maximum. So that means marginal revenue should equal marginal cost.
Wow.
Indeed. I'm sure Donald didn't tell you this.
Our economy teacher, Stephen.
Yes. Anyways, you can now tell Donald that you learned the secret of where this formula comes from. It actually comes from calculus, that the first derivative must be 0 for a maximum then. This is exactly the stuff you will do in first year economics. First year economics.
Should you also tell him that you are better?
Yeah, go ahead. Right, so next topic we're going to look at are tangents and normals. So like I said, more chocolate. This lesson is quite easy, especially compared to the last lesson. So, we remember what tangents are. What's special about a tangent? Andrew? Come on. What's special about a tangent?
It's the point where a line
Yeah?
crosses.
Yeah? Crosses what? A curve.
A curve, yeah.
How many times?
One.
Beautiful. So, it crosses only once. This is a tangent. And we would like to find the equation of the tangent. So, let's have a look at an example. Let's say we have something like y equals, I don't know, 2x squared plus 3x plus 1. And we would like to find the tangent here at the point 1. So, I want the tangent at x equals 1 to the curve y equals 2x squared plus 3x plus 1. So that means I want to find the m and I want to find the c. Now the good news is we have a very easy way to find the m. What is the slope of the tangent? What's that called, the slope of the tangent?
Not gradient, but derivative, yeah. And what is the derivative here in this example? Yeah. And what is the x in this example? So the 7. So we have y equals 7x plus c. So far so good. How can I, yeah? X is 1.
Oh, okay.
Yeah. How can I find the c? Do I know x? Do I know y? I can know it, yeah. So if x is 1, what's y? 6. So this point here is 6. 1, 6. 1, 6 goes in. 6 equals 7 plus c, so c equals minus 1. So the equation of the tangent is 7x minus 1. So like I said, compared to the last lesson, this is not as difficult. Write this down and I'll give you one to try. Sun, rain. Presently, sun. And cold mixed in as well. Who are you missing? Nader, I know, had to go somewhere, and Lee is still at GNIB, having a great time. And who else are we missing?
Karen.
Wasn't she in earlier? I thought I saw her. No? Where is she? Do you know? Sick? GNIB? Don't know? Sick? Okay. If you're going to say a student is sick and then start laughing, it makes it look like they weren't really sick.
Yeah, she was really good.
Is she really sick?
Yeah.
Okay. Who else am I missing? Is Omar here?
Lucas.
He was here earlier. Where's he gone as well?
Oh, not even my class. He got sick.
Did he?
Yeah, I saw him walking.
Oh, did you? Yeah.
I'm not sure.
Yes. Faisal looks out for you.
He was waiting for...
Yeah, I know. This is what I'm asking. Where did he go? He'll probably come back now in a minute and have an interesting story.
Yeah, he didn't bring his glasses.
Got lost. Okay. Did you write this down? Yeah? I'll give you one to try now. Well, no, I need to go on. You can grab it from the video. Alright. Here's one for you to try. Wong. Omar. Okay. Let's have something like, maybe not a quadratic, something a little bit different. We'll go with a function like this: y equals root x, and we'll keep it nice and simple. We'll go with 4. And my question is, give me the tangent line at the point 4. So I want to find the equation of the tangent shown. Okay, I'll give you a minute to try that.
Find
the equation of the tangent shown.
in the exam, does it make a difference if we write y dash or dy over dx?
Does actually. If you write y dash, you will save a little time each time, giving you more time to do other questions. Yeah. Good thinking.
Efficiency.
Oh yes, important. Yeah. Actually, it'd probably be even quicker if you didn't even write the answer down and just thought of it in your mind. Yes, yes. You got it? Yep. You have it, Andrew? Yep. Omar, did you get an answer? Nearly? Yeah. Yusuf at the back? Yeah. Okay. All right. Did you just say your answer was cute?
No, his knees was.
Oh, sure, yeah.
Did you like this all day?
Every
I suppose I only have to see him for 12 hours a week. You would see him 25 hours a week? Okay, that should be enough time now. Yes? Let's have a look now. So the first thing I need to do, I'll change this into x power a half. So m equals dy dx equals a half x minus a half. But I actually know what the x is here. What's the x? 4. So I can just make the x equal to 4 here. And you can hit this in on the calculator if you want, but I think the answer here is 1? No. 1 over 4. So you now have y equals 1 over 4x plus c. We need a point. We know that the x is 4, and what would the y be if x is 4? 2. Putting that in, we get 2 equals a quarter times 4 plus c, so c equals 1. So you have y equals a quarter x plus 1. Like that. Right, so that's tangent, pretty easy. Let's have a look at normal now. Can I scroll down?
Wait, isn't x, how did we get 5?
Using the original formula.
This is the
Oh,
equation.
okay.
Yeah. Okay, what is a normal? So,
Perpendicular to the tangent.
perpendicular, correct. So the normal, if I draw it here like this is the tangent, and this line here, which is perpendicular to the tangent, we call that the normal. So the only difference is when we calculate the slope, we need to change it because it's perpendicular. Minus as well. We did this in lesson 2. Parallel and perpendicular lines. Let's have a look at an example.
Why do we get the normal? On what purpose?
Yeah, the reason tangents and normals are important is tangents are useful for approximating functions, and normals they have more of an importance in physics, because a lot of things in physics we care about that we want to look at the part that's perpendicular. So for non-engineering uses, I can't think of much use for normal. Tangent has uses in business, economics, that it's useful for, you'll discover later that it's useful for approximating difficult problems by using tangents, graphs and all this. Normal wouldn't have much use to you. Okay, so let's find normal here. Let's go with something like log x. Y equals log x. And let's look at the point 2. And this time we want to find the if this is the tangent, we want to find the normal. Right, I'll give you a minute to try it, because I think most people here should be able to do it, and then I'll do it on the board. So please try and find the normal here.
The gradient of the normal or the equation of the normal?
The equation of the normal. Finished it? Yes? Okay. One more minute. So, you're finished. Sit quietly. Practice your meditation. Focus your thoughts. Think positive things quietly. Okay, do we have answers now? Yes? So when I look at the graph, I can see that got an answer yet? When I look at the graph, wait, guys, listen. When I look at this, I can see that the m in my answer is probably negative. Did you get a negative m?
Yeah.
Yeah. And the c is probably positive.
Yes.
So that's a good sign if you've got a negative m and a positive c. Let's calculate the answer. Before I start, let's get the y. What would the y here be? Log 2, which is 0.69. I'll just write log 2 to be more accurate. So, the slope is dy dx, which in this case is 1 over x, which in this case is 1 over 2. But we don't want that slope. We want the one that's perpendicular. So the one we really care about should have slope minus 2. Very good. So we have y equals mx plus c. So y equals minus 2x plus c. Now I can use my point 2 log 2 in here. So I get log 2 equals minus 4 plus c. So c equals 4 plus log 2, or 4.69 if you have 4.69. Yeah. So my answer is y equals minus 2x plus 4 plus log 2, or y equals minus 2x plus 4.69. You got that? Yeah, good. This is normally a section A and section B question. You can see it in both A or B, which is good. It's not that difficult of a question to do, and there's only really two types. They either ask for the tangent or they ask for the normal. Sometimes what they then ask for, which I'll do now, is they sometimes ask something like, where does the normal cross the x-axis? So, how... Yeah, what do I do to get that?
4.69 divided
Yeah, well, how do I get it? What do I do? to find this point.
Zero.
Y equals 0. So I have 0 equals minus 2x plus 4.69. So this point here would be 4.69 divided by 2. Or, to be precise, 4 plus log 2 divided by 2. What else could they ask? Well, they could ask where does it cross the y-axis, or, you know, I mean, just basic questions here to try and make it a bit longer. So it's not that difficult. It's actually a good question here.
Section of y and x then area of the triangle.
That's the other one. Yes, they would ask for this area here, which is, if you know this number and you know this number, it's a half the base by the height. So in this case, it would be something like area equals a half times 4 plus log 2 over 2 times, and what's the height here? 4.69, which is 4 plus log 2. So that would be 4 plus log 2 squared over 4. Yeah. So I've reached the limit here. I can't think of anything else that they could ask you here for these. So they're all straightforward. I'll let you try the questions now. How many will I make you do?
Not all of them.
Not all of them. Agreed.
Do we have time to start another topic?
The next topic is integration.
Okay.
Yeah, you'll feel in a better mood to do it after the weekend, I think. Yeah. So if you want to start these, I would say homework question 1 to 10. Can you start them now, please?
Can you show them in the board?
Yes. Give me a moment. Can I close this here because you want the questions up? Questions 1 to 10.